Hi friends, welcome to this mathematics session. Today we are going to deal with Euler's theorem. Before understanding what is Euler's theorem, it's very important to understand what is homogeneous function. So let us understand what is homogeneous function. Let us consider a polynomial function, say f of xy, be a naught x raised to n plus a1 x raised to n minus 1 y1 plus a2 x raised to n minus 2 y square, so on, an x raised to n minus n y raised to n. I can write it as a raised to x raised to n, a naught x raised to n, a1 x raised to n minus 1 y1 plus a2 n x raised to n minus 2 y square plus an n minus n is 0. Anything raised to 0 is 1. So I will just keep it as 1. So it becomes y raised to n. Now friends, look at the degree of each term. So look at this term, this, and so on and so forth. So you're going to see that the degree of this term is n. Right? And the degree of this term is also n minus 1 plus 1. It's again n. You're going to see n minus 2 plus 2, it becomes again n. Here you again have n. So each term is having the degree as n and it is unique. So throughout the function, the degree remains the same, that is n. So such functions which are having a unique degree, the degree of each term should be the same. So such kind of functions is called as homogeneous function. For example, let me consider a function x cube plus y cube divided by x plus y. Now look at this function. This term is having a degree 3. This function is having again the degree 3. I mean this term of this function is having 3. And look at this. The degree of this term is 1 and this is also the degree is 1. So it is having a unique degree. The function in which all the terms are having unique degrees, such functions are called as homogeneous functions. Okay, friends, now let us take x raised to n common here. So it is going to be a naught remains in the bracket, then a1. So if I take x raised to n common, it becomes x raised to n minus 1. If I take x raised to n common, then it only remains is x raised to minus 1 y1. So x raised to minus 1 can be written as 1 by x. X raised to minus 1 can be written as 1 by x. So 1 y and x plus is 2. Then if I take x raised to n common, then only remains is x raised to minus 2. If I take it into the denominator, it becomes x square and this remains as x y square. In the similar fashion, a raised to n, since I have taken x raised to n common and there is no x raised to n term, I need to divide the term by x raised to n. So this is how we can do. So you can see that this whole function is of the form y by x, y by x, y by x, y by x with some term raised to it. So I can write it as f of y by x. So f of xy can be expressed in this form, x raised to n f of y by x. You can take instead of f, you can take phi or any other functions for denoting it, phi of y by x. So this is how you can denote. So any function which is homogeneous can be expressed in this form. Okay, x raised to n phi of y by x. Or you can express it as, if I take y raised to n common, then the equation would have been like this. The expression would have been like this: x raised to n phi of x by y. So this would have been also the case. So what we take common becomes the first term, and again the remaining terms go in this way. So this is how you can express a homogeneous function. Let us look at the statement of Euler's theorem. If u is equal to f of xy is a homogeneous function of degree n, then prove that x dou u by dou x plus y dou u by dou y is equal to n times u. So this is what we are going to prove. So we know that if a function is homogeneous, then we can write it in the like this form. Okay, so if u is a function, homogeneous function, we can write it as x raised to n phi of y by x, where n is the degree and x raised to n phi of y by x, this is the expression which we already dealt with a few minutes ago. Okay, now let us consider this as equation number 1. So we need dou u by dou x. So what we are going to do? We are going to partially differentiate it with respect to x. So we are going to take LHS and we are going to prove the RHS. So differentiate u or equation 1 with respect to x partially. So how will we do the partial differentiation? Dou u by dou x. You can see that x is in both terms, so we need to use uv formula. So what is uv? Uv rule, uv is equal to u v dash plus v u dash. If it comes u by v, then we need to use v u dash minus u v dash whole dash v square. So we have uv rule here. So we will keep u as constant. We are going to differentiate with the v term. So x raised to n is kept constant. Differentiation of phi of y by x. Let us differentiate first phi of y by x. So it will be phi dash y by x. And again, we are using the chain rule. So the internal function is y by x. So x is in the denominator. It is of the form 1 by x. So we know differentiation of 1 by x is minus 1 by x square. Differentiation of 1 by x minus 1 by x square. How? So if I take x raised to n x above in the numerator, it becomes x raised to minus 1. So we can use formula x raised to n is equal to nx raised to n minus 1 formula here. So n is minus 1 x raised to minus 1 it becomes minus 1 x raised to minus 2. Okay, so this is how we can do minus 1 and minus 1 by x square. So we are going to get the same result. Okay, so we are going to use that formula now. Internal differentiation, y is kept as constant, so I am not going to do anything with y. So minus y 1 by x is minus 1 by x square. So this is how you are going to differentiate. Plus, here I wrote plus. So v, now we took u and v. Now we are going to keep v as constant and we are going to differentiate u. So phi of y by x, and again differentiation of x raised to n. So x raised to n differentiation is nx raised to n minus 1. So I can write nx raised to n minus 1. So in the proof, what to prove is x dou u by dou x plus y dou u by dou y is equal to nu. So I need x as a multiple of this term. So I don't have x, so I need to multiply by x. So let me just multiply on both sides by x. So it becomes x dou u by dou x is equal to x raised to x is kept as it is. So you can see that x raised to n, here in denominator we have x square. So I can just bring it to the numerator, it becomes x raised to minus 2. So it is of the form like this, like a raised to m a raised to n is a raised to m plus n. So here I have x raised to n and as denominator I have x is 1 by x square. So if I bring it above, it becomes x raised to minus 2. So using this formula, if I add, it becomes x raised to n minus 2. The same thing I am going to do, x raised to n minus 2, and y is kept as constant and minus 1 is there because I have minus sign. What is left out? Phi of y by x. This is the rearrangement I am going to do. Again, phi of y by x, and since I am multiplying the x throughout the equation, I need to multiply. I multiplied for this term. Okay, I need to multiply for this term too. So it becomes x raised to n minus 1 into, if I multiply x, it becomes x raised to n minus 1 plus 1. 1 gets x raised to n. So n x raised to n. You got this term? Okay. Now what you are going to do? Here x raised to 1 into x raised to n minus 2. Using this formula, if I add both, then what I am going to get? N minus 2 plus 1. So it's n minus 1. So x raised to n minus 1, y minus n out 5 y by x plus n x raised to n 5 of y by x. So let me call this as equation number 2. This is x into dou by dou x. So this is the one part I got. Now I need to consider the second. So let me just use this result afterwards. So we are going to do the second part of this differentiation. Okay, friends, if the quality, if the letters on this board are not distinct to you, you may click on the right corner of your mobile screen. You have 3 dots. If you just click that, you will get an option called quality, and if you click 480p, then you can get a better resolution video. Okay, we had the initial equation. What is it? What was it? X raised to n 5 of y by x. So this was our equation 1. So now we need to differentiate this equation 1 with respect to y, because I want dou u by dou y. So dou u by dou y partially. I am not doing the complete differentiation, I am doing the partial differentiation. Dou u by dou y x raised to n. Since there is no y term here, so this is going to be the constant. Only this term we are going to differentiate. So it is going to be 5 dash y by x. The internal differentiation of this function. So if we are going to differentiate y, then x will be a constant. So x remains the constant. And differentiation of anything with respect to that term itself. If it is x and you need to differentiate with respect to x, then it becomes 1. So here I am differentiating y with respect to y, so it becomes 1. So it remains just 1. Okay, so this x will come above using the laws of indices. So this is equation number 3. So dou u by dou y. So I need y into dou u by dou y. So I need to multiply y into dou u by dou y. So it becomes x minus 1 5 dash y by x, and again multiply by y. So this is equation number 4. This is equation number 4. And we had equation number 2 as x dou u by dou x is equal to this was our equation number 2. So guys, this is equation number 4 and this is equation number 2. Now what we are going to do, we are going to add, because these are the terms should be added. Okay, x dou u by dou x plus y dou u by dou y, we are going to add. So equation 2 and 4 should be added. So we are going to add equation number 4 and 2. Add equation 4 and 2. So it will be x dou u by dou x plus y dou u by dou y. This is the LHS, and RHS is minus x raised to n minus 1 y 5 dash of y by x plus n x raised to n 5 of y by x plus x raised to n minus 1 y 5 dash of y by x. So we need to cancel out, because we have same terms. Okay, x raised to n minus 1 y, x raised to n minus y, 5 dash of y by x, 5 dash of y by x. So it is negative and another is positive. We can just cancel them out. So what is left? N x raised to n 5 of y by x. If we just closely look at this term, x raised to n 5 of y by x, you're going to see it is our initial equation, that is u is equal to x raised to n 5 of y by x. This was the first equation. So you can see that it is the same. So you can just substitute in place of that term, you can substitute u. So it becomes x dou u by dou x plus y dou u by dou y is equal to nu. So this is the proof for Euler's theorem. I hope friends you have enjoyed this session and been able to understand what has been discussed here so far. So we are going to meet in the next video. Till then, take care. Thank you. Have a nice day.